Have you ever used an app or a website that just works? It feels incredible. And then you try another one that's supposed to do the exact same thing, and it feels completely broken. Well, today we're going to dig into the hidden qualities that make all the difference, the stuff that separates the tech we love from the tech that drives us crazy. Oh, we've all been there, right? You're just staring at that little spinning wheel of death, waiting for something to happen. You tap a button, and nothing. It's that moment of pure frustration. But what is actually going on under the hood that causes that feeling? And believe me, the stakes for getting this wrong are sky high. Get this, a staggering 88% of people are less likely to come back to a website after having just one bad experience. Think about that. One slow page, one clunky button, and you've probably lost them for good. So it turns out the problem usually isn't about the list of features. A buy now button is a buy now button. The real magic, or the epic fail, is in how well that system does its job. When you click that button, does it feel instant? Do you trust that it worked? That's everything. That's the difference between making a sale and losing a customer. Okay, so this how well thing, what do we actually call it? Well, there's a technical term for it, a kind of secret ingredient that architects and engineers are absolutely obsessed with. So let's pull back the curtain and talk about something called quality attributes. Now, the official, kind of nerdy term is non-functional attributes, or NFAs. And I know what you're thinking. That name is terrible, right? Non-functional makes it sound like they do nothing at all. But as we're about to see, that could not be farther from the truth. And that's exactly why quality attributes is a much, much better name. Think about it. Is performance non-functional? Of course not. A slow website loses a ton of money. Is security non-functional? No way. A data breach can destroy a company's reputation. These things are absolutely functional. In fact, they define the actual quality of the entire experience.
So here's maybe the easiest way to break it down. The functional part is the what. The system has a buy now button. Simple. The quality attribute is the how well. When you click that button, it responds instantly. The functional part is the feature list. The quality part is the feeling you get when you use it.
It's kind of like buying a car. Its main function is obvious, get you from point A to point B. But you never walk into a dealership and say, "And I'd like the model with airbags, please." Or, "Does this one come with the feature where it doesn't break down on the highway?" No. You just expect those things. They're assumed qualities that are absolutely critical, even if they're not the flashy features on the sticker. All right, let's zoom in on one of the biggest quality attributes of them all, performance. Because when we talk about speed, it gets really interesting. It turns out what we feel is happening is often way more important than what's actually happening. This is such a cool concept. Real performance is just the raw number, right? It's measured in milliseconds. But perceived performance, that's all psychology. It's about how fast the system feels to you, the user. And you bet clever designers have all sorts of tricks to manage that feeling. And here's exactly how they do it. Think about a progress bar or a loading screen. It doesn't actually make the process any faster. In fact, technically, it uses up a tiny bit of power just to draw itself on the screen. But what it does is brilliant. It gives you feedback. It tells your brain, "Hey, don't worry, I'm working on it." And that simple communication makes the wait feel way shorter and a lot less annoying. But sometimes you can't just rely on psychological tricks. Sometimes you need raw, real-world speed. So let me tell you a quick story. Way back in 2002, a team was building this massive SMS system, and the requirement was insane. It had to process 10,000 new text message records every single second. So months into the project, one of the architects finally asks, guys, have we actually checked if this is even possible? So they built a tiny prototype just to see what their design could handle. And the result? It could handle 500 records a second. Not 10,000, 500. They were 20 times too slow. The entire project was about to go up in flames. And the lesson they learned from that near disaster is so important. You have to find your biggest, scariest risks and test them first. Building a quick and dirty prototype is like sending a tiny scout boat ahead of the Titanic to check for icebergs. It might feel like a waste of time, but it can literally save the entire project from sinking. Thankfully, that team did eventually figure it out. So how do you do it? How do you actually build a system that can be blazingly fast and handle millions of users? Well, let's look at some of the core strategies. Okay, one of the biggest weapons in the arsenal is something called caching. And just look at these numbers. They are mind-blowing.
Getting data from a computer's main memory is over 500 times faster than from a standard hard disk. And from the CPU's own cache, it's literally tens of thousands of times faster. So caching is just the simple art of keeping the data you need as close as possible in the fastest location so it's ready to go in an instant. Another huge strategy is scaling. So when your app gets popular and you need more power, you basically have two choices. You can scale up, which just means buying one giant super powerful server. Or you can scale out, which means adding lots of smaller, cheaper servers and spreading the work across all of them. Scaling up is easier at first, but you eventually hit a hard limit. Scaling out, that's how giants like Google or Netflix can handle the entire planet's traffic at once. So let's actually visualize how scaling out works. Most systems start out pretty simple, just a single chain. A user request comes into a web server. That server talks to the main application, and the application pulls whatever it needs from a database. Nice and simple.
But then, what happens when you suddenly get a flood of new users? Well, that single web server gets totally overwhelmed. It's now your bottleneck. So what do? You just add more web servers, and you put a little traffic cop, called a load balancer, in front to direct requests evenly. Boom. Bottleneck solved. For now. Because a system is a chain, and you're always only as strong as your weakest link. Now that your web servers can handle all that traffic, all that pressure just moved down the line, and pretty soon the database becomes the new bottleneck. So you scaled that part out too. Building a huge system is really just this constant game of finding the next weakest link and breaking it. Now, this all sounds pretty straightforward, but it brings us to maybe the most important idea of all. You can't just have everything. You can't just maximize all of these qualities at once. Building great technology is really an art of making some very difficult choices. It is the ultimate balancing act. Because these quality attributes are constantly fighting each other. You want the most secure system possible. Okay, great. Now your users have to create a 32-character password with symbols and use 3 different authentication methods. That's not very user-friendly. You want lightning-fast performance. Well, that's going to cost a fortune in fancy hardware. A great architect knows you can't have it all. Their real job is to find the perfect balance for their users and their budget. So the next time you open an app and it just feels right, it's fast, it's easy, it's intuitive, just take a second to think about the invisible work that went into it. What hidden trade-offs do you think the engineers had to make between speed and cost and security to give you that seamless experience? Because once you start looking for these hidden qualities, trust me, you'll start seeing them absolutely everywhere.